Hi everyone and welcome back to the AI Concepts with Coding from Scratch series. In this video, you will learn what is Ensemble Learning and also how can you implement one random forest classifier using Python. We are not going to using here any building library like Scikit-Learn, TensorFlow or PyTorch. We are going to coding it from scratch. If you want to learn Python, data science, machine learning and GenAI, subscribe my YouTube channel. What is Ensemble Learning? Ensemble Learning is a machine learning technique that combines multiple models to improve the prediction accuracy. It used to address problems like classifications and regressions. That's when ensemble learning is nothing but the groups of multiple machine learning. So there are three ways you can actually design here your ensemble learning method. So the first way or first technique is nothing but using here different types of machine learning models. So in the example you can see here using the linear regressions and the SBM support vector machines decision tree and the KNN. You can use here up to n types of machine learning models. And after that, what I can do is simply going to use it to do the predictions. Now, there is a second way you can also use here to design your ensemble learning method. The second way in you can using here the same types of machine learning algorithm. Let's say linear regressions, linear regressions, linear regressions, and the linear regressions. So you can use the up to n machine learning model in here. So what are the difference between this one and this one? See, in this case, using the different types of machine learning model, and in this case, using here the same algorithm at a time. Same algorithm at a time. Also, you can see here data is not changed, but in here we can do the data change or data should be changed. So you can see here, but data is changed. That's mean in the number one, we can using here different types of machine learning model to do the predictions. And in here, we can using here same types of machine learning problems or machine learning model, but data is changed. So this is nothing but used in the case of random forest because we know that random forest is nothing but a group of decision tree. So in this case, we actually using the linear regressions, but in the case of random forest, we can using the decision tree. There also one third way you can combine this both term just like this one and you can use this technique for building this ensemble learning method. So now the question is, how can you do the predictions? Because we know that in the traditional machine learning model that actually used for training as well as the testing or the predictions. So what about the prediction tasks for the classifications? So we have one model, let's say linear regressions, it's giving the output as a 1, and we have the another model, let's say SBM, give it here the 0, or let's say decision tree, give me here the 1, or the KNN, let's say let's give it here the 1. So we say that we have 1 0 and 1 1. Okay, so what we can do for the case of classification problem is simply going to counting here the majority for here. So here we see that majority is nothing but the 3, I mean 1. Okay, because we have the voting three voting, it's called voting for the lost regressions or the linear regressions or the decision tree or the KNNs. That's mean what I can do is simply going to choosing this one as my predicted values because we are going to using here the majority counting on here. So in the case of classifications, now what about the regressions? What about the regression problems? So in the regression problem, we simply going to taking all of the predicted value in the from a continuous. You can see here 7.1, 4.1, and we have the 8.2 and the 7.3 up to n. You can go to the up to n format, and after that we simply going to join all of them and divide the number of machine learning model. It's simply we can using here the mean technique in order to calculate the predicted value for the regression problems. So see, we're using here the majority counting in the case of classifications, and we are going to using here the mean in the case of regressions. You can see here taking the mean in the case of regressions. Now, what are the types of the ensemble methods? So I'm going to discussing here the 4 types of ensemble method. There are so many are available in, you can go on the Google, you can search for that. So those are the 4 usually mostly used technique in the case of ensemble learning. So first case is called the booting ensemble. Second one is called the stacking. Okay. And third one is called the bagging, also called the bootstrap aggregations. So in this case, they're actually using the random forest. This is nothing but examples of that. So that's been example in the example actually, random forest is using the bagging technique. And third, you have the most favorite one. It's called the boosting. Okay, so you have the three algorithm: ADA boosting, gradient boosting, and the XGBoost. So XGBoost is most popular in the case of Kaggle competitions because it's really popular in the case of Kaggle competitions. Using this one, we can got in here so much kind of accuracy, got accuracy. Okay, so those are the types that I'm going to be discussing here later on. So our first type is called the boating ensembles. So what actually happening in the boating ensemble? Boating ensemble is same like the first example. First example they actually do while we define here the ensemble technique. So base model are different. Okay. So in the case base model are different. That's it. We have one data set and we are going to apply here the different types of a machine learning model on this case. Okay. On this case, you can see here SBM, a decision tree, the linear regression, the logistic regressions. Okay. And classification problem actually using the measured accounting, and for the regression using the mean of that you can see on here. That's when this technique is nothing but one boating technique. Okay, boating and ensemble learning. Okay, and after that what we have the stacking. So what are the stacking? So the stacking, what you do the same thing but slightly different than the boating sampling or boating ensemble learning. So you have the data set, then you have the several types of machine learning models, and then we simply going to pass all of the input inside another machine learning models. See, we have the several types of machine learning model, and after that we simply going to pass in those output to another machine learning models, and this machine learning model give me the output. So output of a SBM, DT, I mean decision tree, and the KNN directly take as an input by L1, I mean logistic regressions, and assigned weight to each and every model. That means what actually happening here, the data set is passing inside this three model, and three model output is passing as an input to this LOR, and this LOR giving me some kind of weight. Okay, give them some kind of weight. So how the weight is actually initialized? Let's say SBM give me the high accuracy. In the case of this data set, that's mean it having the high weight. You can see here, best result it give the high weight, and low or bad result it will give here low weight. This is how we can actually calculate the weight, and calculate means I mean initialize the weight for each of the machine learning model. This is how the stacking method actually work, and this is how the boating ensemble actually work. Now our next technique called the bagging technique. So in the bagging technique, we're basically using here the example as a random forest, because random forest is nothing but one bagging technique. So what actually happened in the random forest? We're using here the same types of machine learning models. That's when decision tree. So in the bagging method, bagging also called the bootstrap aggregations. Bootstrap aggregations. So in the bootstrap, what I can do aggregation, what I do, we're simply going to using here same types of 10 types of machine learning models. You can see decision tree, decision tree. Now it's called the random forest. It's called the random forest, but data is different. Data is different. You can see data is different. So let's say I'm taking one example. Let's say I have a data set about the let's say diabetes predictions. So let's say I have 1,000 samples in my data sets. So what I actually do, I randomly choosing here. Let's say I'm randomly choosing 500 sample. So randomly I chose here the 500 sample and passing it inside this first model, and next 500 I'm going to pass into this machine learning model number 2, I mean decision tree number 2, and next 500 sample I'm going to pass it here. It's maybe the duplicated problem, but model are same. That means we're going to divide them into 5,000, 5,000, 5,000 multiple times, randomly choosing the 5,000 sample from the data set and try to pass it inside each of the model, and our model give me some kind of result. This is called the bagging method. Okay, let's go to the next slide, and you can see here we have in the next method called the bootstrap methods. So you have a 4 method, right? Boating, stacking, bagging, and the boosting. So what actually happened in the boosting? See, all of the data is going at the parallelly. It's going the parallel. This kind of thing. Parallelly, we're going to go to the data, taking one sample and passing all the data in the parallel format. But in the case of boosting, what actually happened? The data is directly go inside our model, go inside our model, and let's say this model, let's say I'm using here the three same model. That's the logistic regressions. Logistic regression 1, 2, and the 3. So what actually happening here? This model may be doing some mistake, having some error. So in order to removing this error, this model passing this output to the next model so that he can improve or he can boast his machine learning model predictions. So in the case of boasting, that was the boasting your data. I mean, your data is boasting and try to minimize the error in the case of boasting method. Boasting method, right? So क्यों हम यहाँ पर ensemble learning पढ़ रहे हैं? क्यों? Why actually reading है the ensemble learning? Because random forest is working in this case in the ensemble learning. In the upcoming, while actually joining any company, while you are creating your own company, you need to using his ensemble technique. You have to using his ensemble technique to actually solving so many tasks, because you cannot using here one single machine learning model to solving one task. You need to using different types of model and try to combine them. It's called hybrid or the ensemble learning. Okay. So this is one graph. So you can see here, in the case of bagging, our data is passing as a parallel in the from a parallel. Okay. So you have a CSV file. We simply passing this data to this, this, and you're simply going to create a sampling of the data and passing to the classifier 1, classifier 2, and classifier 3, and finally you can got in the output. Okay. But in the case of boasting, I mean, there's a difference between the bagging and the boasting. You can see here that is passing to here, that is passing to here sample data, classifier number 1, and after that, if the error is calculated on here, it will pass into the next one. It's like next one. Okay, that's when this data is passing as a sequential manner. You can see on here, sequential manner. That's when in the case of boosting, data is passing as a sequentially and try to boost your machine learning predictions. Okay, this is the difference between the bagging and the boostings. So what are the benefits of the ensemble learning? The first benefit is improvement in performance. It will improve the performance of that. Let's say in the diabetes, if I using just one single model, I may be getting some wrong output. But if I using the ensemble learning, yes, obviously I can get the better output because it will using multiple number of machine learning model at a time. The second one is called bias and the variance. Bias and the variance. So what is the bias and what is the variance? Bias is nothing but training data, and variance is nothing but the testing data. I mean unseen data. That's mean our actually what our motive to using the traditional machine learning. Our motive is to making here on low bias and the low variance model. Low bias mean it will working in the training data working perfectly, and also it will working to the unseen data or the task data perfectly. That's why it's called the low bias and the low variance. But in the case of decision tree, it will give me the low bias and the high variance. In the high variance, okay, that's mean what we need to do. We need to removing this. I mean, we need to optimize this high variance and try to make it lower. This is the ensemble learning is solving these problems. Okay, it will try to make it low variance, but it's quite tough to make that. But it will trying that. The second one, it's a high bias and the low variance. High bias, it means it will not working correctly in the case of training data, but working in the case of testing data, but it not work. It not a go to, because in the case of linear regressions or the loss regression, this problem will occur. So it reduce the bias and the variance. It reduce the bias and the variance. That's the benefit of non-ensemble learning. And third was it robustness, same like the bias and the variance as well. Okay, that you can see that's the benefit of the using the ensemble learning. Now we're going to see that what is the random forest. So random forest is nothing but the group of or combinations of decision tree. So many tree while it combined it will creating one forest like that. It can be the Sundarban, it can be the Amazons. So random forests are for supervised machine learning, where this is level target variable. That's what supervised means, it having one supervisions, it having supervision, or it having the target columns, it visible. It's called the supervised machine learning problem. So what is the unsupervised? Unsupervised problem statement don't have any target columns. It don't have any supervisors. Okay, that's called the unsupervised learning. So random forest can be used for solving the regressions, numerical target variables, and classification for the categorical target variable problems. We know that random forest is used like that. So if I see that in this picture, you can see here we have training data number one, training data number two, training data number up to n, and you pass into each of the decision tree, and then each of the decision tree is passing to here and try to do the voting. It will try to voting that, or taking here the most frequent answer and try to give the predictions. So this is called the bagging. That's called the bagging. We already learned about that. You can see here this is called the bagging. That's called the bagging, right? You can see here in the bagging we're using here bootstrap applications. You can see on here. Okay, that's why random forest is nothing but one bagging technique. You can see on here it's a bagging technique, right? So let's take one example. Let's say we have a certain of data set. It's called the instance, and you pass into this decision tree number one, decision tree number two, and decision tree number three. Okay. See, our structure of the decision tree may be vary. It can be the vary. So let's say I'm taking here class number A as apple, class number A as a apple as well. That's when class number A is predicted as apples, and class number A for the tree two is also predicted as a apples. So what are the tree number n, or let's say three? It will classify them as a class number B, I mean banana. Okay. So majority voting is nothing but apple. That's mean our first final class is nothing but apples. That's mean we are going to using the multiple number decision tree, and after that is simply going to using the majority votings. Okay. Then we got in here the random forest. So you can see here we have the data, and we divide them into some kind of samples and passing it inside these bootstrap samples, and our sample is passing to our machine learning model, and our machine learning model is aggregating the board, I mean taking the majority of that in the case of classifications, and in the case of regression is taking the mean of that, and after that it will give me the result, give me the output. So that's why ensemble learning is important. इसलिए हमने ensemble learning पहले पढ़ा, क्योंकि random forest में ensemble learning use होता है, इसलिए. Also, one more thing, if you're not watching my videos regarding decision tree, just go on the series in the AI concepts recording from sketch. Otherwise, you can go to the uh, machine learning model from a sketch series as well. Because I'm already creating here two separate series for that, so that you can access it easily. You can go on here learn about the decision tree, because if you don't understand about the decision tree, you cannot building here this random forest. Then what we have in the bootstrapping, because bootstrapping, so bootstrapping is nothing but we having several types of machine learning model, and after that we're taking here number kind of samples. Let's say we're taking here the 500 subset of that, and then I'm going to using here the same kind of data, uh, actually random data, and after that we'll do the predictions. But here are three techniques you can using here in the case of sampling. Okay, because you can see here randomly sampling here, let's say 5,000 data, but there is also way to sample in the data. The first one is called the row sampling. It's called the row sampling. And second one is called the column sampling. And third one is not the combinations of this row sampling and the column sampling. In the row sampling, let's say I have the 1,000 rows. So you can take in the first, okay, you can take in the randomly randomly taking the 5,000 subset for that. But row sampling also defined in the two terms. One is called with replacement, and third one is called the without replacement. So in the with replacement, our data may be having some duplicated, but without the replacement, it don't have any duplicated. So if I having the 1,000 row, if I have the 1,000 row, I mean 100 row, so I cannot using here this without replacement, because without replacement don't have any duplicates. So I cannot divide them into three models at a time. I need to using here the two models in these cases. If I have this three model, I cannot using here this without replacement. So while I do the coding, I can using here this with replacement one. Okay, not without replacement. So in the with replacement, our data having some duplicated value. Okay, that's mean from 1,000. Obviously, it may be the probability of that it may be having some duplicated value as well, but little bit. So since your data is different, so your decision tree will be different by structure. That's mean because you're going to passing a different types of data as from a sampling, so our decision tree may be vary. Okay, maybe having the several enough to our levels. It may be, let's say, for our decision number one, it may be have the two layer. Decision number two, it maybe have the three layer like that. Okay, but the structure of the decision tree may be vary just because of sampling. So we see the row sampling. Row sampling mean take nothing but the taking the row for that. So what are the column sampling? Same thing. Column sampling means features. Features is called the column, right? So simply going to taking the all of the columns, and we're taking the sample of them. Let's say I have the 10 sample, or let's say I have the 10 columns, so I'm taking the 8 for that, or let's 7 for that, or 5 at a time for that, and using the same technique with replacement and without replacement, same technique. But this is happening in the case of row sampling, not in the case of column sampling anymore. Okay, so this is how the bootstrap actually work. Now what are the aggregations? Same technique, taking the majority and the mean of that, that's called the aggregations. That's why boosting is called the bootstrapped aggregations. In the bootstrap, we simply do the sampling, and the aggregations we take in the majority of that. In the case of regressions, we take in the mean of that. So this is how the random forest is actually work. Now we simply are going to creating here our random forest from scratch without using any module called Scikit-Learn. Let's start. So in order to creating here the random forest from scratch, you have the knowledge about the decision tree, because random forest is nothing but one combination of decision tree. So I already make the videos regarding the decision tree as well as the theoretical part. You can go and check out the videos in the description. So this is the code for that. We simply could using here the numpy and creating here one node class as well as a class for decision tree. I am simply going to running this out. Okay, and this is about predictions. Okay, so now we simply going to creating here a class for the random forest. So let's get a class called random forest. Let's go down and create a class on here. Let's say class, let's say random forest classifier, and then let's say def init, and then we have the self and the number of estimator. You can say that how many trees it have, number of estimator. Let's say by default I will passing a 10 trees, and max depth of the trees, let's give it here 10, and the max feature, or how many features it have, let's make it none, because I don't know that how many features we have in our datasets. Then we simply going to initialize the number of estimator, the max depth, and the max features. So let's say self dot number of estimator equal to number of estimator. Okay, and then you have the self dot max depth. So max depth is nothing but the max depth, and self dot max feature, and max feature is nothing but the max feature. Okay, max underscore features, and then to creating here another list that's called trees, where we can store all of the trees on here. And you will know that random forest classifier is working in the case of backing. Okay, if I go the slide again, then you can see here this is the random forest, and if I go here, you can see here it will creating one formula called bootstrapping sample, and also stand for backing, and backing is nothing but stand for bootstrap applications. How are you going to passing here all of the data in the form of samples, and after that you can pass it inside the models, and we also do the voting for that. So let's try to go on here and try to implement it right now. So you have the trees, because how you're going to storing here all of the decision tree, we have the series of trees on here. So we're simply going to creating here a function called bootstrapped sample, because this is nothing but a sampling, right? That's a self and x and y. And how can you do the sampling? If I go on here again, so you can do the sampling in the two way. uh, we can do the sampling just kind of, it can be the randomly chose with replacement and the without replacement in the case of row sampling, and in the case of column sampling. You can see on here row sampling and the column sampling. We can do that. We can randomly choose the value with replacement and without replacement. So we're going to choosing this one with replacement and try to creating this one. We're going to taking the 500 subset. This one is nothing but our example cases. So let's go on here and try to choose here the randomly. So you can simply go into checking all of the samples from our x dot shape. That's x dot shape of 0. Or you can got in here all of the sample for the row. Because when actually using his x dot shape, we can got in here the row and column, like that row and column. So because you're going to using here the row sampling, and you're going to using here the with replacement, so taking this number of sample from the row. If you are using here the column sampling, you can also using here the one instead of using zeros. Then you're going to using here indices. That's indices is equal to np dot random, because it's a random choice, random dot choice, and then inside that you can passing here the number of sample. Okay, and the size is nothing but our number of sample. Okay, number of sample itself. And then we're going to pass in here the replace equal to true, so that it will replace all of the value and not going to creating any duplicate. And you can returning here the indices for each of the data point. So let's say indices, and then you're going to pass in here the indices for the y as well. Let's say indices. That's it. Okay, that's our bootstrap sample. Now we're simply going to fit it, because in random forest we having one method called fit. So you can using here, let's say def. So let's say def fit. Let's say to cutting this out, fit, and which one taking the self and the x and y. And then we can simply going to creating here a self dot trees. Okay, trees is equal to this one. I mean this one. You can use it here or use it here, up to you. Okay, you can give it to here or give it to here. You can also do the initialize in this part, or you can do the initialize in this part as well. And after that we can taking the sample, okay, number of features from x dot shape of what, because the feature is nothing but the column. How many column it have in the data set, it's called the features. Now we're simply going to calculate that maximum features, because we're passing here the maximum features. Okay, so you can by default we can calculate this one, and you can store it inside the variable called max feature. So let's say max feature, and then you can using here self dot max feature, because we already have the self dot max feature. If see how you can taking this max feature high, because you already taking it from the user as a parameter, but it's none, you can see none. So initialize here the variable, but we are not assigning here any value. So what are the max feature? Max feature is nothing but if it is coming from here, we can directly pass it to here. Let's say max features. Otherwise, we're going to pass in here the number of features as a max features. Let's me see, because the max feature is right now none. You can give it here any kind of feature, because if you're doing any feature engineering or a feature extractions in the case of machine learning, so obviously you don't put in here any kind of value. So you can give it here any kind of value, and then it will directly pass into here. Okay, if it is a math, if the value is okay, if the value is not none, we can directly store it inside this max feature. But if the value is not available, we can simply go into taking the number of features as a max feature, as a maximum number of features. Now we can simply go into iterate to all the value from here, because this is one this is a list of feature, right? So now we simply going to using here self dot number of estimator. Number of estimator is nothing but mean how many decision tree we're going to use in here. If I go on here, you can see here bootstrapping nothing but using here the number of up to n to number of decision tree. So it's nothing but how many tree it have. So number of estimator is mean how many tree you can choosing in here. In the case of random forest, see you using here three trees. So how many trees you're going to use it here? You wanted to use, okay, as the users. So it is passing to inside the parameters. I pass it as a by default value as a 10. So we're going to iterate to all the value from here and try to using here the decision tree. So that's a decision tree, and you already implementing here the decision tree, and the max depth equal to self dot max depth. I mean depth of our decision tree. How depth? Because in trees nothing but is having the left child and the right child. It will go up to again and again and try to creating here of the child. Okay, so that's called the tree. This is how he actually created. And then after that we simply going to creating the sample using this bootstrap sample. So let's say self dot bootstrap sample, and you're going to pass in here the x comma y. So this is nothing but my bootstrap sampling. So we can using here x underscore sample and y underscore sample, and then we're going to selecting the feature random feature, because see we are going to doing here the row sampling. So for the feature sampling, because we have the feature sampling or the column sampling, you can see it here column sampling, we can also doing the none, or others you can do the combination of that. You can also do the column sampling, otherwise not. I am simply going to using here the column sampling as well, because you discuss about that. So how can you do that? Simple, same thing. Instead of using here the number of sample, we can using here the number of features. So you can copy this thing, same thing. Okay, you can copy the same thing, and then we can give it here the number of features and how many number of features you have. Let's say number of features. And then we are going to pass in here the size is nothing but the max features. Okay, because size is the maximum feature of that how can actually capable to select. Okay, so we're going to use it. Let's say a variable called, let's say, selected features. I'm following the slide that we already discussed about that. Just follow the slide and try to creating here this random forest. It's easy to use. Okay, and after that we simply going to creating here a subset of the selected features so that you can use it and try to predict it. Okay, that's the selected features. So you can using here x underscore sample because we're taking the sample for that using this bootstrap sample, and we are going to taking it here row and all of the selected feature, I mean our selected columns. So which one is nothing but a subset. So let's x underscore sample subset, and then you can using here this tree to fitting it out. So let's do the fitting. Let's say tree dot fit, and you're going to passing here x underscore sample, and then we are going to using here this subset and the y sample. Why subset? Because you're going to also doing here any column sampling and try to using this one subset and try to predict it, fit it. Now we simply going to fit it all of the decision tree. Let's say I'm going to passing here 10 decision tree. It will try to fit all of the decision tree with the sampling data and try to store it inside this self dot trees. You can use it here or use it here. It's up to you. You can use it inside this feed or you can also use it here. It's up to you. You can initialize in one time at a time. And then you're going to using here self dot trees dot append, and inside that you can passing here the tree. It should be the tree, and then you're going to using here selected features. That's the selected features. Okay, now you can using here predict function. That's a def predict, and you can using here self comma x because in the prediction you can passing here the x data. Now we have all of the feature, right? So from here, what I can do is simply going to taking the majority voting from here for the majority voting because we are going to creating here on classification model. That's mean we're going to taking the majority voting from here. If you are uh, using any regression problem, if you are building any regression method, you can using here the min method. Okay, because you can using here as a classification model. So that's why we're going to using it here as a then how many majority vote we have. So it's also your homework that how can you also creating here the random forest regressors. It's your homework. Okay, so we're going to use it here. Let's say tree prediction. So in the types of predictions, what you can do, you can simply going to using here this array, and inside that you can using here, let's say for tree and a feature, because this decision tree actually append, we append here tree as well as the features. As well as the feature, that means we can taking all of the trees and the features from self.trees because it's stored inside these trees. Now these trees and this feature we can simply going to use it to predict them. So let's say tree dot predict, and you can pass in here the x, all of the column, and all of the features. These features, okay. So this is that my predictions. So you're going to be using here tree and the features because in the self dot trees we have all of the decision tree output. So we got in here the predictions. Now we can do the majority voting. We can do the majority voting because you're going to creating here a random forest classification problem. So you can using here the majority voting. If you are having working in the regression problem, you're using here mean of the each value. You can take it here. So let's say taking the majority vote. Let's say majority votes, and then we're using here. Sorry, it's gone. Majority board because unfortunately actually using the this control jar, that's why. Okay, so we can use it here. Let's say we can using the counter, but it also actually import it. So let's say using here, let's say from collections, importing here the counter. You can also using here this tactic as well for counting this one. Okay, this np dot unique, and you can do the counting of that. Okay, so I'm going to using this class called counter, And inside this counter, I'm going to passing here these three predictions, and then you're going to using here this all of the column and then all of the row. I mean all of the features, and then you're going to using here the most common, which is most common features. So you can using here, let's say most common, and you can passing here the first one, and let's say 0th and 0th. So it's giving me all of the features column. So now how the features coming from here? Feature is coming from the x dot shape of 0. Okay, so you can using here for I in range of x dot shape of 0. Sorry, it's not a shape actually. It's nothing but because in our x you have all of our data, and we're simply going to use it to taking the most common value, because this value is already available inside its predictions, and you give it here x dot shape 0 so that it can taking the predictions based on these features. Okay, for I in range we having all of the features and most common, and because all of the value is stored inside this t dot predict, so taking all of the row and all of the columns, and this I is nothing but coming as a data. Okay, so we can simply go into returning here this np dot array of majority board. Let's say majority board. So this is how we can creating here the random forest classifier. Okay, your job is to your homework is doing here the random forest regressive. Let's say homework random forest regressor. It's your homework. You can go and you can also upload your code in our Discord server as well. Okay, okay, upload your code. Okay, let's say code into Discord server. Let's say Discord server. Okay, okay, that's your homework. Now we're simply going to do some examples. Try to taking some example and try to predict it. Let's say x is equal to, let's say, np dot array, and you can using here, let's say 1 comma 2, let's say 3 comma 4, let's say 5 comma 6, 7 comma 8, 9 comma 10, and then you have the 11 comma 12, let's say. So we can using here, let's say y is equal to, let's say, np dot array, and then let's say 0 comma 0 comma 1 comma 1, let's say 1. Okay, that's it. We can now using here this random forest. Let's say random forest. So it should be the random forest, and you can passing here the number of estimator. Let's give it here 10, and max depth, let's say give it here, let's say 5, and let's say max feature, let's say 1 features. Okay, so that's our model. Let's give it here model, and you can using here the model dot fit. Let's say model dot fit, and you can using here x comma y, and then you can taking here the predictions is equal to model dot predict of x. So that's our predictions, and let's try to printing here the prediction. Let's say print, let's say predictions, and you can using here this prediction. Let's say predictions. So you have the if string. So that's a prediction you can got in here. Okay, so you can use this one in one real-time data set as well. So let's start creating here one data set using the Scikit-Learn. So let's try to using it. Let's say Scikit-Learn dot data sets. We can inputting here the make classification, because this is a classification, right? So you can using here make underscore classification, and you can using here, let's say x comma y, and let's say make classifications, and you can using it here, let's say number of sample, let's say 1000 samples, and number of features, let's say 10 features, and let's say number of informative, let's say information formative is equal to 5, and let's say number of redundant, LUD and DNT redundant, let's say 5, and random as to, let's say 42. So it's not changing the state anymore. So you can using here the train, test, or split. Otherwise, you can just simply going to passing it here. Okay. So going to using this one. Let's say I'm going to copy the same thing and I'm going to paste it to here. And let's see how can we got the predictions. So we have the prediction. So this is how we can got the predictions, but this X and Y is not here. Okay, cannot import the make classification. Okay, so it's nothing but A is here. That's why. So we can start actually start predicting, and you can see here to start predicting how many data it have. Okay, so you can take it here. Let's say I'm going to see here 5 1. You can see that how many classification it have. Okay, you can use it. You can use it in any kind of data. You can use it for the breast cancer data set as well. Okay. So this is all about the random forest classifier in using Python without using a Scikit-Learn module. So I hope you like this video. So make sure to subscribe our channels and share it with your friends so that also hit the bell icon so that you can notify when our new videos coming up. So thank you and bye bye.